Yeah. So welcome to today's class. So today's class will majorly feature a recap of yesterday's class, and it will be more or less a traditional Q&A questions. We covered a huge chunk last week, and that's entailed Python, exploratory data analysis, and then a bit of sklearn machine learning. So it's a theory set of theory foundational and pillar topics. So that's why it will be very vital for us to move on. If you understand this segment, next sections, next set of topics are very incremental, and this would be foundational on it. It's building blocks. So if you've gone through the topics, just like last week, I am monitoring the chat as I am teaching. So if you have any questions, just post on the chat. I will attend to it immediately. Just like I said, one step at a time. So no question is stupid. No question. If you feel confused, and I'm sure whatever is confusing you is confusing a lot of people. So please feel free to ask the questions. So so today's class will be a lot of recap from last week class, and we would further delve into the red wine problem we were working on last week, and then also pick one, and then I'll teach you some new concepts, and then we will end on question and answer. So please feel free to ask your questions. So as of this point, right now, any question from last class, from this class, any question? Yes, no, no, yes. Okay. Silence means yes. Silence means no. Sorry. So now recap of
None for now, sir.
none for now. Okay. So recap of last class. We did some things on Python, and did some things on string manipulation, right? We did some things on Python. I showed you how to name a variable, how to show that you know how to make assign a name to a variable and then use it in different versions, how to do square root, how to do string manipulation, basically slicing. If I want to get course, I can just slice it, how to access the first time, how to access the last time, things like that. Then there's a section I didn't teach, which is formal is the way you display your results, basically reporting. So if let me see. If I run this cell, unrecognized. If I run this cell, it's just showing that I want wherever these curly braces are, I want D and cost to be there. So if you see curly brace, comma, complete, comma, Python, comma, this. So it's the first curly brace is replaced with D, the last curly brace is replaced with cost. It's just basically reporting formatting options, so you can it's just as it's seen. So this F means float, this D means decimal, so that okay, I want this float to be in two decimal place, I want this decimal to have three digits, something like that. So for a sign, for this, something like that, it's not anything crazy, it's just print. There is some, so this is just, I know last week can I zoom in the screen, please? Thank you. Yes, I can zoom in the screen. But is this better? Jonathan, is this better? Yeah. Hi Uche, welcome to my channel. So now, so for example, there is a concept. When I started learning Python, there's a concept that was very useful for me, which is DIR. DIR can make you seem knowledgeable even if you don't have any knowledge. So what that means is this. So DIR means like directory. What are the functions under a variable that you can use? The sub functions under a variable that you can use. So say for example, the string is st. Imagine I have no idea of anything about string, and I want to know what are the values of variables I can use. So the string is course 1, 2, 3, 4. Now this is a value or a variable. Now people in coding or that have experience coding will be like they understand what I mean. So if I want to say st dot upper, I can just use dot because upper is here. I can do st dot translate. I can do st dot title, right? And it will bring something out for me. So if it is dot upper, right, it will bring it up even if I did not know, right? So now you can also read up, remove prefix, remove suffix, partition, make trans, lower, L join. You can also read up all these what these sub functions mean. Some sub functions may require input, right? But dir, as in many cases, help me know that there's a variable. These are the capabilities of that variable. And then I might now go and read up what is, so this variable is a string, right? Is a string. What is string dot casefold? It will tell me what string dot casefold is, and then I'll know. In many cases, we don't know because a programmer cannot just, have all this in their head, right? So sometimes it's just good to know that you have this and you can access it. String.upper to hidden cells. So so in this case, this is what string.rstrip. So if you want to know what that, so for example, let's say casefold, right? Casefold. So what this is telling us is that if you want to know about casefold, I can just say help string.casefold. It will tell you what casefold is doing, right? So that is something we can do. Now, this is regex, some other abstract things. Actually want to walk us through data structures. So,
I have a quick question.
yes, please.
Sorry, before you move on. The function you just did, does it show you all the methods only or other functions that can be applied to the variable?
So it shows all the functions that can be applied to the variable and its or the data structure. So, say for example, and all the sub functions. So if I have string.upper, now please let me know if I answer your question. I can also do this. I can also do this. And it will also tell me what I can do string dot upper dot, right? To that variable in that state. Do you understand?
Okay.
So if I have three, I can't I can't do that. It should give me an error, right? Because
Mm,
three is not a string, it's basically based on that data type.
okay. Okay, that's interesting. Yeah, thanks.
Um any other questions, please feel free to interrupt me. And please, your question should not be limited to what I'm currently saying. It should be from the previous class. After today, if nobody say anything, I would assume that we are all at least 2% or 3% good in a scale of 1 to 10. We are very good at machine learning, data analysis, and SQL at least, right? And that means we can tackle at least maybe 10% of all the regression problems on Kaggle. Are we agreeing to that? Please let me see yes in the comment section. Hmm?
Not at all. Not really, sir.
Then please let me hear your
uh,
question.
sir, I want to ask a question quickly, sir. What you are doing now, are you doing it directly online or on your normal local PC, as in
I
on
am
desktop,
doing so
the installed app?
um um I'm coming. I'm trying to get to, so I sent Google Classroom. Let me see. I don't know if you have access to the Google Classroom. I sent it. I sent all the um if you go to class 6, if you go to class 6, if you look at, I sent all the installation guide. of what you need to install it on your local computer. So if you want to use a video, there's a video for you to watch. If you want, if you don't, if of course I'm sure people are managing data, there's a page that will help you, that you can just make offline and then use it to download all the softwares. Can everybody hear me? Abraham say you can't hear me. Can everybody hear me? Yes. Okay. Abraham, I think you should check your audio. It's from probably from your end. Samuel, I don't know if you got around to this. So under week 6 lectures, there are some links on the collab, on all the notebook we used, and the case study we worked with, and then also installation guide. So if you go through this, you will see how to install the packages so you can work on it offline. Make sense? So you just download everything and then you work on it offline. So
Okay,
if you have
thanks, sir.
if you have any issue, just come under the comments. Let me know. Either we can reschedule something 1v1, and then I should click on my speaker. Okay, Abraham, click on your speaker. Okay. So now, Kelechi, you raised up your hand. Kelechi, please.
Yeah, okay, I did, sir. Good evening, sir.
Hi. Good evening. It's always good to hear your voice.
Hi. Good afternoon. Okay, sir. So, you said you should ask question that doesn't really have to do with this class precisely. So,
Yeah.
I think I'm literally very confused because at ALX, I'm just as data science, we just did the foundation, which mostly was soft skills. So, I'm transiting to my tech track by September 11th of this month. Right. So most of all those things we've not been taught, mostly what we were taught about communication, data visualization, data analysis, and all that. So we've not been taught Python and all. So when it started with you, I tried to download it. It wasn't just working. So I used ChatGPT to add ChatGPT. ChatGPT said it was supposed to be pre-installed on my on Mac laptop, but I don't have it. I checked, I didn't have it. I tried to download it. They said I should download something. And for me to get this, it wasn't just working
So
for me to
so
download.
you could not get Jupyter Notebook and all the libraries and packages to work on your computer offline. That's
Yes,
what that's.
please.
Oh, okay, okay, very good. So what's going to happen is this. I think people that have problem installing online, installing packages, we can do from 2 to 2:30. I will just open be here. If I don't know if everybody's available at that time. If you're available, and then of course I will extend the recording. I can just show you, okay, you know what, this is the link to do, this is what to reinstall. On my computer, you will see that the package is already pre-installed. So it will say pre-installed. But if not, we'll do it and you will show steps if you have problems.
Nigerian time, sir.
Oh, oh, my bad. My
7
bad.
to 7:30 Nigerian time.
7 to 7:30. 7 to 7:30 Nigerian time. My bad. So
Yeah. But sorry, Mr. Tululope, 1 second. Kelechi, would you prefer to work online or offline? I think we should start from that. Where would you prefer to work, Kelechi?
Okay, sorry. So any of the two is okay for me. Online, offline is fine.
Yeah. So if you don't mind working online, the one that you don't have to bother about installation would be better. Just go to collab.google.com on your computer right now, and you'll be able to follow Mr. Tolulope as he's going through these things. Collab. Let me drop the link.
Okay, so please, thank you.
Yeah, I will drop the link here. So for people that don't mind, that have internet connection that are stable enough, it is better to use online because you don't have to install anything. Everything has been done for you by Google. You just start coding away, testing out everything. But if you don't have, a suitable internet connection, you can then follow through with Mr. Tolulope how you would install it on your local computer to be able to use it offline. I'll drop the link to the online version so you can follow right away.
okay. Thank you. So I think that's working. So any other questions, please feel free. Maybe one day in this class I will do giveaway to the most
Sorry.
engaged students in
Hello,
this.
sir.
Yes.
Yes, sir. I just want to say that why some of us want to use the offline as well is so that because it's not every one of us that have direct access to internet regularly. So we can just do a lot of things offline if we have them downloaded, and then it will enhance more productivity and more perfection. So by the
Yeah,
time you are coming online, it will be very, very easy to do a lot of things. That's
exactly.
what I just feel. Because
Yeah,
even
yeah.
when we were taught the blogging and then website creation, some people said, okay, just do it online. The one I was taught long ago was directly online, but I had to learn the local one. Through the local one, I was able to do a lot of things. And then I could just save my time and then all the stress that I would just sit down, because there are some there are some software on someone's laptop that probably the moment you go online and probably they are on, there might be a kind of a conflict. You understand? So
Yes,
that's why some don't want to quickly go online and
I,
then they just want to do
I
the
totally,
work properly.
I totally understand you. So that's why from 7 to 7:30, if you can just stay on, we'll tell you all the packages to download for offline installation, and then you download it, and then you can now, at least, as you said, improve productivity offline. Make sense? So from 7 to 7:30, that arrangement will be made, right? So
So,
yeah, this is where we are. I'm going to call names randomly of people that have not heard their voices. Josephine, Chisom. Any questions? Deborah, right? Any questions based on that? So if there's no questions, let's continue. So now back to Python. I will spend Deborah, any questions?
I'm kind of joining late, and I guess I'm still playing catch up here. So my question is, if you can do a run through of some data and apply Panda and probably scikit-learn to clean the data and visualize the data. Is that something you've covered in the last class, or am I just playing catch up?
So yes, Deborah, you didn't, obviously you didn't join our last class,
No,
right?
I
So
was not here last time.
yeah, so what's going to happen is, yes, there is a run through one, there's a video recording of the previous class two, and also yes, I will touch some aspects of it today. So it will be a win-win-win for you as we run through the class.
All
So
right,
yes,
thank you.
this class, we should be able to have something. So yes, one of the goals at the end of this class is to show you that we are going to pick any random after we are going to solve two questions on Kaggle, and to also show you that if you have pre-cleaned data, there is nothing you cannot get. As regards regression, there's nothing you cannot get from from it. You already have the skills and the workbooks to do it. So from this day, you can actually have a pre-made resume that, pending the time you finish this class, you can apply for a machine learning job, right? That is one. So now I'm going to spend the next 10 minutes on Python just to show you some of the things we missed out. If you have any questions from previous classes, previous things we've done, please let me know. So now in Python, there are times when you want to print things and you want to be able to visualize them better. So in this scenario, there's something called regex expressions. So in regex expressions, this means new line. Just like when you're typing in Microsoft Word and you press enter, it will go to new line. This in this means tab, /n means new line, /t means tab, right? So in this kind of case, this will be a new line means enter, A, enter B, then press your tab to C. So it will be A. When you press enter, B will go to the new line, and if you press tab, B will go to C. If I say two new lines, I will press enter twice. So it will be A, then a white space, then B, right? Because I pressed enter twice. You understand? If I don't want tab and I want just space, it is just going to be space, right? Space is just space. So this is just formatting options and printing options, reporting options. Now, booleans. Booleans, like I said, a computer programming language is just like you are asking. Imagine it's an interaction between two people. In some interactions, there are sometimes when you're asking someone a question and it has to be logical. Did you steal the money? Or did you go to this place? When I tell you to go and grind pepper, did you go and play football? All those things in programming language are, I know many of us are guilty of that. All those things in programming language are what? They are called booleans here. You right? Booleans are true or false. Thank you. Booleans are true or false. So in for example, is 5 greater than 5? The answer is what? False, right? 5 is not greater than 5. That's all he's asking. If 5 is 5 less than 4, right? Is 5 less than 4? False. Is ABC equals to ABC? False. Why? Because this is lowercase, this is what? Uppercase. Right? So if I say is 4 equal to 4, now is 4 equal to 4? The double equal to means you're asking a question. The single equal to means is definite. So if I say A is equal to 4, I mean that wherever I see A is 4. But if I say is 4 equal to 4, I'm asking a question, it will become true. But if I turn it to this, it is not a boolean anymore. It's not a boolean anymore. 4 is equal to 4 is, what are you saying? 4 is 4, right? Is 4 equal to 4? That's this. Is 4 greater than or equal to 4? Is 4 greater than or equal to 4? That's true, right? Because it is equal. Or is 5 greater than or equal to 4? So in some variables, so say for example, in our next class, we'll do some time series prediction, which is maybe stock price or some maintainability data that has to do with that is time dependent. So say for example, you work in ShopRite and ShopRite is asking you to give us some marketing insights. So you want to say, oh, every Valentine or September is coming. What are the things we should put in the first part of our shops? Because what do people buy most in September? So you are going to go and analyze all the September of previous years. That is time series data. It is time and period dependent. So when we do that, we will ask some questions. We will ask the code some questions, and the logic should bring something out. So that's where Boolean matters. So in many cases, you will see if sentences, and I think that is covered here, right? So now, so this is Boolean. Boolean is just basically to confirm if it is true, if it is false. All right. So now printing has to do with reporting. If I say print, it will print. I think we have, sorry, I didn't print the first. I didn't. So it will be import. We saw this last week to import libraries. Because I have not imported it for this new session, that's why it is complaining. So print is just to print. So printing option is that once you see F, print float to do 2 decimal places. So it's going to print 415 blah 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 0.86, right, to 2 decimal places. So if I want it to 5 decimal places, I just increase it to 5 decimal places. Now print, we discussed this. Yes, this will cover wherever those curly braces are. Now print test is 0.475. So wherever this curly brace is, the first one will go. The result of the second curly brace test is test. Now this test is already this number. You to print it in 2 decimal places. So this is what it will give us. The result of the test is, what is the variable? Test is what? 0.475. So to 2 decimal places, 0.48. Please, any questions? While Google Colab has libraries installed, we still need to import in each session. Yes. Google Colab already has them pre-installed, but Google Colab, per your instance of Google Colab, or when you open Google Colab, it doesn't know the library you want to use. So you have to specifically or explicitly say import this. So don't think Google Colab is not some, it's just think of it as your locally made Jupyter notebook or environment. Joy, I hope I answered your question. So now we are in lists. So this is some aspect of data structures and data structures. Some winding up. Now, I am surprised that on this call, I'm the only one talking. This call was supposed to be about questions. You people are supposed to be blasting me from left to right. For the first time, I brought water, but it's one of two things. Either everybody understands everything I said, which I'm praying that's the issue, or nobody read over the week. I know we are not like that. I doubt it. I really doubt it. I know that everybody studied because when I went on the notebook, I saw a lot of people. They were also on the notebooks, so I doubt it. I know we all studied and we already understand it, so it's fine. It's fine. Mr. Asia, on one of these sessions, we are going to do some breakout sessions where we'll give everybody notebook. All those online will share their screens and then we will see what they are doing at a glance. Should we do that? Yes or no? Nobody.
Yes.
We should do that. Very good. No problem. So now, list. List is a, you know, the way we have number. We have number. We have a float. We have integers. We have strings. Now there are some things that can contain everything together. So say for example, if you go and register for your NIN or your driver license or you go to the hospital, I can create a list of your metadata or a JSON of your metadata. That's a data structure. So I can say, for example, I want your name. So if you look at this, I want your name, I want your age, your driver's license number, I want your this. There should be something that should say, oh, I want to aggregate all your information together. Now, those information about you will not be in the same format. Everything about you is not all numbers. Everything about you is not all words, right? So if you have your passport number, they have your blood type, they have if you are a donor, if you are an organ donor, they have if your age, your height, your eye color, everything. All those attributes are saved in a metadata for you. So list is kind of like that. List has the ability to save different types of data type. So now this is a string, this is an integer, this is a float, and it will save it in a bracket. So instead of me to have all these things in bits and pieces, all I need to go is I need to say wherever I say L, all this information will go in there. Just like string, we can slice. If I now want your name or the string parts, I can say give me L0 to say it will give me ABC. If I say L1, it will give me the number. If I say L2, it will give me the float. So we can also slice. We can increase it. List can go as far as breadth or depth goes. Now, if you now have a list that you don't know, so say for example, I'm working in a driver license office, I call the list of all your details. Now, how before I do that, the attributes of list is square brackets, square brackets. Square brackets, anything embedded in a square bracket is a list, right? Now, in okay, so if I want to, so the length, how many things are inside this place? One, two, three. The length of a list is what is that's how you get the length of a list. If you notice, we used it in scikit-learn last week. List and data frames are very relatable. Sometimes I match them together. Now, okay, I've done this. Now, this is also L1. So if you want to get the last term, who can tell me what if I want to get the last term, what should be here? Who can tell me what should be in that bracket if I want to get the last term? 2. 2 is correct. Imagine I don't know the length. Imagine I don't know the length of the list. What should be the last term?
That's one.
-1. Ah, Joy movie. Joy
We,
movie.
we have badass people in
Oh,
this room. Oh.
yeah. Everybody's on me, but a round of applause. A round of applause. A round of, ah,
There's a way you can do round of applause from Teams.
from,
Sorry, from the software. Let me see. Okay, applaud. Oh yeah, there's an applaud here. Can you see?
ah,
Yeah.
you know that Joy, you're from Ondo State, Abi? I'm just kidding. So now, same thing, the way we did in strings, we can also do it for lists. We can slice to get each element. So this L1, you know, we said Python is zero index. Israel, you raised up your hand,
Sorry, I was trying to do more applause.
right? Right. So L1, zero is index. So the first element is zero, this is one, and this is two. So if we do L1, L1 will give us 13. L0 will give us ABC. Now, slicing, we told you -1, right? So it will slice but ignore -1. So this will give us ABC and 13. The last part is always ignored. So now we can also concatenate lists. We can concatenate lists. So what is L? L is ABC 13 3.14. Right? So if we want to merge more elements to list, all we just need to want to add CDE. This variable is float and this integer. np.exponential, we can see that it has increased the length of lists. So if I now come here and I say, what is the length of L? That should give me, oof, good, good. Now, who can tell me what I did wrong? Now, this would have worked. So let me do this. M is equal to this.
Fine, yeah.
I didn't save it into a variable. That's why it didn't. So if I say length of M should be what? 6. If I now say, show me what M is everything. Now, I can also multiply the list by 2. L, I didn't save it. L is still this. So I can multiply the list by 2. And that means that it will be ABC 13 this, ABC 13 that. Right? It will multiply the contents by 2. So that's list. Now, this is L. Now, to add elements, now you can see, now, we added elements into the list because we know what the elements are. There are scenarios where we have to dynamically, without human intervention, add things to the list. So we use something called append. So say for example, what is L? L is ABC 13 this. Append will go to the last part of the list and put something there. So ABC 13 2.85. So this is assuming, so say for example, right, I have, don't let me use the example. Now, append will go and add whatever you are adding to the last, it will become the new last term in the list. It will increase the length of the list and become the new last term in the list. If I want to pop will remove the last term of the list. So if I say L.pop, it will remove the last term in the list. Let me put it back. I'm going to put 2.85 back. Now, but I can also pop a particular index. So if I want to pop index 0, so I want to remove ABC, I will remove ABC by popping that index. Let me go back to having L again. Oof. I'll go back to putting L to what L is because I've changed its state. And then we can pop anything we want. So if I want to pop the last term, I can put pop -1 or nothing. By default, it will pop the last term. All right? 0, 1. Okay. I know what happened. This and then 2.85. Add 2.85. Pop -1. So everything goes back to normal. So that's about it. So we know how to declare a list. A list is anything in a square bracket. We can multiply entries in the list. We can concatenate, which is you can add 2 lists together with just plus. It will fix the entry. We can pop, we can append. So those are functions. Now, based on what I told you, look at this. We can now do DIRL. So if you don't know anything about list or you've forgotten, just do DIR. It has saved me a lot. We can see that there's append, there's clear, there's pop, there's remove, there's reverse, there's sort, there's insert, there's extend. We can discover all these things. So far, the data type is a list. Now, so you can see there's sort and there's reverse. Ooh, we did not know before, but ooh. So now let's look at this. Let's imagine L is CDERA, and we want to sort it to ABCDER. There's something called sort. It will arrange it in ascending or descending order. If we want to reverse it to ERCDAB, it will arrange it. Make sense? So far, any questions? So I'm not supposed to do a lot of teaching today, but you people are not asking questions. So you just like the sound of my voice. No problem. So now there's something called nesting. Please, I recommend that those that have not gone through the notebook should please go through the notebook at least once. Understand what each enter is doing, relate it, and practice. Right? Just practice it on your own. There are courses. There are courses like Udacity that can help you with um, Python. That can help you. I think I'm just trying to show you one that I have done. So, introduction to Python programming. Introduction to Python programming. It will give you data types, data structures. It will go into very comprehensive teaching. And in each class, there are, sorry, that has changed. There are exercises for you. There are exercises for you to test your knowledge. So please, in your free time, and this is what will stand you out. This is what will sell you apart, because in your interviews, these are the things they will ask you. All right. So now there's something called nesting. So in another 5 minutes, I'm going to end Python. I really just want to touch um I want to touch dictionaries and then continue, because we will use dictionaries in um in data structure. So now a we can have a list of lists. We can have a list of lists. So in this scenario, we can see that there's a bracket list. We can have a list of lists. We can have a list of lists, depending on how you want to do it. But we can have a list of lists. I don't recommend a list of lists or a list of because it would consume time. So now, we can have a list of lists. Now, if you say type is a list, but it's a list of lists, right? Now, if you want to, you can, the way you index or slice or access elements. If I want to access matrix 1, what will it give me? It will give me that list in that position. So if I want to access this 3 now, it will be matrix 1 of 0. Give me the 3. So I'll index that. Okay, the mini list, this is it. Then the elements inside the mini list, this is it. Matrix 1 of 2, 5. So this is matrix 0, matrix 1, matrix 2. So matrix 1 will come to this one, then matrix 2, 0, 1, 2, 5. Right? Makes sense? So far, any questions? No questions. So now, dictionaries. Like I said, dictionaries are my favorite data structure. Why? Dictionaries have something called key value pair. Right? Key value pair. Now, what is key value pair? It means that it's just like when we were doing graph for WAEC, it has x and y axis. The corresponding y has a corresponding value for x, and that's how we plot the graph. So in dictionaries, if I want a car is Audi. The car is Audi. Quantity is 12. Color is black. We can save attributes in key value pairs. So another way to save a license is that, okay, if I come to name, Tolu, age, this, and this, we can have a key value pair. So if I say D is this dictionary, right? D is this dictionary. I want the color. The color of D is what? Black. I don't need to be cramming numbers like lists and say 0, 1, 5, this. I want the color, right? I want to add quantity. So irrespective of what the quantity is or the position of the quantity, I just know that this is a dictionary. It has a key called quantity. I want to add to that quantity, then this is what I will do, right? Abraham, please, any question? Abraham, you raised up your hand. So quantity moved from 12 to 14. Now, what if I want to, so this is how to, so if you look at a list, I told you that a list is a what? A list is a square bracket, right? Curly braces is for dictionary. So now they created an empty dictionary. This is how to create an empty dictionary. Now they want to create a key. The key is brand. The value is Audi. The model, they created a key. So this is what the dictionary will look like. Brand Audi model A5 price is what? 60,000. If I want to add another way to create the dictionary is just this. Just put dict. This is another way to create the dictionary. The same thing. So they're just showing you. Now you can access the keys. You understand? So in list, you can't access anything. So this can tell you that there's something called brand. There's a variable saved in this dictionary called brand. There's a variable called model, there's a variable called price. So you know what you are looking for. Right? So you can also access the values that okay, brand is Audi, model is A5, price is 60,000. And dictionaries is basically one of the what I have noticed is because I like dictionaries or because I know a lot about dictionaries. Um, how do dictionaries look in a table of data? We'll go there when we transfer to data frames. Like so, in dictionaries, the keys are usually the columns, and the rows are. I will show you how to save a data frame as a dictionary and how to load a data frame from a dictionary. So we'll see all that, and this is why I wanted us to reach dictionaries. So now, so we can see what the keys are and what the values are. So in JSON files, I'm sure many people that deal with endpoints and API calls, they come in JSON files. JSON files, if you look at it, they are foundational dictionaries, right? Same thing with data frames. So I think with combination of last class and this class, so last class we talked about variables. This class we've continued those variables, string manipulation into lists, and we've discussed dictionaries. Um, Tuples, files, and sets are explainable, right? So sets, let me just demonstrate what set is. Set is like list
I
and
have
dictionary.
I have a
You have a question, Deborah. Deborah has a Deborah has a question.
sorry. I have a question on tuples. I know that tuples are supposed to be immutable.
Yes.
So I guess the question is on the differences or advantages of using a tuple versus a list. Like in a scenario, I know the best possible scenario I can think of for an advantage of using a tuple is if you don't want someone to make any change to your data.
Yes.
Aside from that, maybe for security reasons, or you just want to lock your data in place. Aside
Mhm.
from that, can you swap your, like if you want to move things around within the data, can you do it, or you just cannot increase the length of the data for a tuple?
So since she asked question on tuple, let's go to tuple. So now she said a big lingo there, which is immutable. So immutable means that when you save your data, it cannot change, no process. So in list, we are seeing that I can come here and I say list. So if you look at matrix, matrix 10 is what? Is 3, right? Because it's 3 from here. Now, if I now say matrix 10 is equal to 8, right? And I say show me matrix, you can see that I have changed that 3 to 8. So that shows that the values in list are mutable. They can change. They are subject to change from processes. Now, there's something, because she used the word immutable, the keys in a dictionary are immutable. You cannot change the keys in a dictionary. They cannot even be duplicates. You cannot have brand Audi and now come here again and say the brand Toyota. It will kick one out. It will kick one out. It will take the most recent one and kick one out. They cannot be brand Audi, brand Toyota. They can be brand. They can be brand Audi like this. So a value can be a list. A value in a dictionary can be a list, right? Can be a list, but they cannot be more than one key, right? And I cannot change the key. I cannot now come there's no way to even change the key, right? And say, oh, change this key to brand one. You have to go back to the when you made the dictionary and change it. Keys in dictionaries are immutable. The way they are is the only thing you can change are the values. So it's only the value part I can change. I cannot change this part once the dictionary is made. No other process can do that. So now, knowing this, if we go to tuples, now it is like a list, but it cannot be changed. They
I
are
have a
immutable.
question. Sorry.
Okay.
I just don't want you to move on because you just said that the brand is the key is not mutable. Is it also case sensitive? So if we had brand in uppercase, would that be considered a different key or would you recognize it as the same thing?
It is case sensitive. So brand like this is this. Let's look for brand.
Mhm.
Give me error that it does not have brand. Let's look for another type of brand. Maybe this one, brand. To say I don't recognize it, right?
Okay,
Because it is what? Case sensitive.
thanks.
Hence, yes. So now, when we go to tuples are just like lists, right? Now, but it cannot change. You cannot change it. Now, you can add to it, but you cannot change it. So, say for example, so now we are seeing something. Square bracket is for list, curly brace is for what? Is for dictionary, and then bracket parenthesis is for tuple, right? So tuple is for this four, right? Now, can I increase? So T is a tuple of what? Four elements, right? You can see this length also comes with what? With list. Can I increase it? I can increase the length. To answer your question, Deborah, yes, you can increase it, but you cannot change the. Can you access the element? You can access the element. See, right? Because Python is zero index, so 0, 1, 2. You can you access the last term? Yes. Can you slice just like you have in list? Yes, you can slice, right? But can you change it? Can you change it? What's the answer, please, before I press enter?
No,
Can you change it? No,
no.
you cannot
Thank you.
change it because it's telling you that it is immutable. No process between now and the end of the world can change it unless you change it from where you created it. Make sense? So now you can also find all these things that tuple has, right? The difference between tuple and list is that I think everything goes to the same. All these dot index, dot count, you can also use them with list, but they are immutable. Now there is something else. It's called there's
Question.
something. Yes, please.
You said you can only change it from where you created it. What does that mean?
So what does
From
that
where,
mean is look at where I created it here. This is the first instance of the list. For me to
okay.
change it, that is where I cannot come in this last part. I'm trying to change, where's the error? I'm trying to change T0 to 2, right? I can only
Mm,
change it from there to,
okay.
and then the journey starts again.
Okay.
But
All
I
right.
cannot, yeah. So, is it only, let me see all the people in the class. Me, I'll be calling names, oh. Yeah, okay. So now, so that's that about tuple. Now, there's something I want to mention. Since went there, you are getting it. So I'm a good teacher, Abby. I'm a good teacher, Abby. You people are whining me. So now there's something called set. There's dictionary, there's tuple, there's list, there's set. But what is set? Set is beautiful. Set is beautiful. I use set and dictionary a lot. So if I say, you see, that's why you should ask questions. All these are things that when I'm at work, they save my life. They save my life. They always make me feel like I'm a genius. So now let's assume, let's just say this was not part of the lecture. I just want to show you something. So let's say I have a list. A list is called list one, and I have it is 1, 2, 3, 4. 4, 5, 6. Now, I have this list. This is a list, and we already know how to list. We know how to slice it. We know how to do anything to it, right? Now, I can convert it to a tuple. I can say tuple 1 is equal to tuple list 1. And immediately it becomes a list. This is called casting, right? I'm casting one data type into another data type. It has become a curly brace. Make sense? List 1. I can convert it back to a list. I can convert it back to a list by doing this. So list this, convert it back to a list, it will become a list back. So I can cast and recast. Now, there is something called set. Set is a tuple. There's something called set. So now I will say set 1 is equal to set 1. I'm casting it to a set. Set is like a tuple, but set will only take one occurrence of its time. So if you look at this, this is 1, 2, 3, 4, 5, 5, 6, 7, 8, 8, 9. This is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. It will not take any duplicates. Set is what you use to remove duplicates. So if you have a list or a dictionary of a million things and you want to have unique values in all of them, you convert it to a set. There cannot be two of a kind in a set. So set is very relatable. So set has curly brace. So it's related to a dictionary. So now set is relatable to the keys in a dictionary. The keys in a dictionary cannot have two of the same kind. They are unique. You understand? It set curly braces too. Yes. So the way I make set is that okay, I can say set 1 is equal to set. And we can add values to a set. Right? So set is related to it's kind of like the keys in a dictionary. They will cancel multiples of each other out. So now it is left for you to go and study the Python and and do this. I hope next class you will have ways and questions to ask me. Make sense? So that's Python basics. All right. Now, last week we also did. Do we get a version? Yes. You've always had version of this notebook. So if you come to this place, you can see Python basics. You can see Python basics. If you click on the link, it will take you to the same notebook that we were using.
Yeah, I know we have that, but you've just made some changes here and you made some notes that I think might be
Yeah.
helpful.
So this is a new link, and I'm scrolling down to show you the changes that I've already made. So this is a new one.
Okay. Okay, so you're the one that can make changes because I couldn't make changes there without losing my.
So yes, you can make changes. I can't, because if you make changes, you can. What you can do is, for example, right? I'm going to go incognito and paste the link so that I will look like a new user, right? So what you should do is you should make a copy so that everybody will have access. So I'm going to do this now. It's going to take me to the notebook, right? And I can't make changes, right? I can't make changes. So what I will do is I'll come here, file, right? And I will save a copy. So if I save a copy, so I must be logged in, right? It will save it to your own Google Drive, and you can make edits to it, so that everybody will have a standard version, which is my version. And then you can make subjective, make notes, copy, paste for your own reference. So everybody have individual copies. Is it clear? Make sense?
Yes, thanks.
Yes. It's like it's me and Joy that were in this class. Nobody else. I miss, I've forgotten her name. Is it Kelechi or someone that was asking me a question last week? I miss you.
Kalisha and Deborah have been very active as well.
Yeah, I know, but I miss them. I miss your voice. I miss everything about you. You know, please, don't let me go this week without losing, not having, the energy from your voice, because it gives me strength to forge ahead. So, exploratory data analysis. Exploratory data analysis. So, let me tell you the truth, right? Um, this is a very compressed course, right? A very compressed course. But everything we are giving you are things needed. Of course, there are things of luxury, and you cannot know it in a day. You cannot know it in a day. You can probably not know it in a week. And of course, we have things going on in our lives. But please, we are showing you that, these are skills currently in demand. This is an opportunity to be in competition with state of the art, with people, you know, across the world. So please, as much as possible, make time to study, go through the materials, go through the course, ask questions. You should ask me questions that will make me go and open my book. Because I was studying, I'm kind of like pained because I was studying before now that this is gonna ask question. I don't want to be going to Google, but all of you have made life easy for me. I appreciate that. Thank you. I'm not ungrateful. Thank you. So now today's class, we've done a recap of last week class. So today's class, we are going to start from where we ended, which is from the um from the pandas we started. Right? What we did last week was we we did a case study of this case, which is red wine quality. Now, what's their problem statement? They were like, oh, in this Portuguese hacienda, right? They want to know if the wine brand is good or not. So, what did they give us? They gave us these features: acidity, citric acid, blah, blah, blah. And the last feature is what they want us to score: quality. They want us to score this quality based on this. So, they gave us 12 features, but the first 11 features they gave us so that we can predict the 12 features. So if they have new data that they give us, 11 features, we should be able to predict it. So that's the problem statement, right? Now, they now want us to create a model based on this data. We downloaded the data on the notebook. I put the data there. Um, where is I think it was on, yes, this is the data. I'm sure, did anybody download it? There's no analysis to show who downloaded it, but this is the notebook. And so for, was it Samuel? Samuel, if you come here, I downloaded a PDF version of this notebook so that for people that are offline, you can just download it. You can just download it and study it without being online. So there's a PDF version just for the study material, and this will also be made into a PDF version. So this one too is also
Yes,
made
I
available.
did.
Yeah, okay, good. I was just telling you in
I,
case you didn't. No problem. So yes. So now what we did last week was we created a Google Colab notebook. We created a Google Colab notebook, and so I have to upload the data. So you see, now upload.
I have a
Um,
question about this actually. So
yes,
I
yes.
did upload data here, and I actually instinctually, for some reason, I felt like I needed to put it in the sample data directory, and it did not work. I had to put it in the regular directory. So what is the sample data? Is this like, what is that? Why is that there?
So did you create a copy? I'm sure you didn't create a copy of this notebook, did you?
I did create a copy and I did do it exactly what you just did now, but I put it in sample data at first and the data would not read because it wasn't, I maybe I didn't like even put the path correctly, but it worked when I did what you just did now. But I'm just wondering what the sample data, what is that? Is
So
that data that,
so because so this is from my directory, right? I have sample data where I was playing with all this from mine. It comes, I think if you open yours, does it come with it, does this data come in by default?
yes, it
Yeah,
does.
it comes with every
It comes
Google Colab
everything. So
notes.
now all these are data sets that you can use to practice machine learning or whatever. So
Okay.
we can, if you want to go into sample data, right? So if I want to have access to this, I'll just copy, rename the file. I'll copy the name of the file, Control C. I'm going to come here. I'm going to say I will say sample data. Sample data is equal to pd dot read csv into brackets. This I will say sample. What does that sound like? Example underscore data slash this. And it's going to be okay. I've not run this. PD 1, 2, and then you can see what sample data is like. So why it did not read for you and dot head because you didn't enter the directory path well.
Mhm. Okay.
Makes
Okay,
sense?
good.
So
Yeah.
it's just picture like your folder for sample data. You have to come here and stuff like that. Oh, we can even predict on this housing value set. So, but that's that. So in case you create a folder and you say that folder is AAIF, right? And you put this folder inside there. This is just like sample data. So all I need to come here, I'll say AAIF slash wine data, and voila, I have it. There.
So I have a maybe upside. Never
Any
mind,
question?
sorry.
Okay.
I was just gonna say, like, how is recognizing the backslash? Because I know sometimes it would. I don't know if you know
So
what
you
like
know,
that.
in current Windows directory or current Mac directory, if you have a file in a folder, so this environment is in this directory or in this hierarchy is recognizing this
Mhm.
environment right here, right? So
Yeah.
it is this is the active directory. So if you have any file, you have to this file AAIF is what is in this directory. You now have to use AAIF to know that this folder is in this location in this active directory.
Yeah, but I thought usually we have to escape the backslash.
Escape it. So
No,
I
I don't
see
know if
like
you know
this.
what I'm trying to say. Yeah, sometimes so usually I'd have to like a double slash, or I thought Python doesn't like
Oh,
recognize.
um, I know where you see the double slash from, but in many situations, in some situations, I think in C++, you do double slash. In some languages, you do double slash, but in Python, it's single.
Okay.
It's okay. So we have moved the file. So good. Now we are in pandas. Are we ready? We're ready. Now, I also want you to know that regression is probably the most applicable part of machine learning, right? Why? Because if you go to car vehicle company, so say for example, you are in Lagos now. You pick your resume, you wear your tie, you wear your shoe, and you head over to Honeywell or to Dangote refinery, and you're looking for a job. Most likely, the first thing they will tell you to do is what? A regression problem, because all their values from all their sensors are numbers, right? They are numbers. So when they give you the numbers, what will you do? You have to predict a number. You have to show all this is good or all this is bad. So most likely all the problems in most industries, one common problem is going to be no problem of numbers, and that is regression. That's why if you understand regression, you can work as a machine learning engineer. Next class, we're going to go into convolutional neural network, which is pictures. We're going to predict pictures and stuff. So but that's why I really want us to use today to delve in these numbers, know it, give you some assignments on Kaggle, and then let's discuss it. So we said when we read the file, we read the CSV like this. We can go to file.head, and then we see all the 12 features from this to volatile acidity. Now, the way I work, and I'm sure some people have different experiences, people have different level of knowledge. Some people even know this thing on this call, they know this thing more than me. Please accommodate my, you know, level of knowledge. So file.ed, right, is to show you the first 5 or 6. And if you want to increase it, you can say file.ed 10. show you the first 10 values. Python is zero index, so it starts from 0 to 9. Right? Now, the way I work, I take the columns as the features. So there are, how many they say? 12. So I will take all the columns. There was a question I was expecting you people to ask me. You did not ask me. Imagine begging for you. So now you can see I casted the features into a list. I converted the features into a list. Now, so if I
So please,
say
can you say what the question is about?
the question you're supposed to ask me,
Yes, please, that we didn't ask.
don't worry, you will get there. I will see again if anybody. Well, we'll get there. It was supposed to be last week. So now, if you look at the features, has all the columns of the. Usually, the columns are features, right? The columns are features, and if I want to describe it, so now, yes, when I was doing something, I will now say, now this is where I want you to know how lists, dictionaries, all of them, all those data structures we talked on earlier, how they all tap into data frame, right? How those topics will make you superstars. So now I'm going to say what is the length. You know the name of this file is called file. What is the length of the file? I want you to see the way I think of. Now this, what I'm telling you is the specific way I think of my when I'm attacking a problem. I'm giving you insight into how I understand things. When you come up with your own, please, you can come up with your own method. So now I know all the features I have available to me. They are what? They are 12. They are the length of features. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, out of the 12, 11 are what I'm going to train to predict the 12th one. Now, but I want to see the length of all the file I have, all the rows. So the length of the features are 12, 11 for training and predicting the last one. The length of all the rows is how many? That's what I use the length of file for. Like a list, length of file is 1599. So all the data entry points, let me see, so that you can be clear. Let me show you. This is Excel, right? All the data entry points to the end is what? This mark is not serious. Yes, it is what?
You are not
1599.
alone in the struggle with how Mac renders Excel.
As in, so you can see it is because it is 0 to 1599, right? So it is 1600. It is 1600. It is 1599. The first column is the column of titling this. That's why it is 1600 on this place. But if you remove this one, every other thing is what? 1599. So that is what this length means. There are 1599. Now, how do I want to make use of this information? When I come to describe is telling me that the count is what? 1599. The count for fixed acidity is 1599. That means that is the same as the number of data. That means that there is no missing data in fixed acidity. Do you understand? Because this is equal to this. Show you. Are you people seeing what I'm saying? So now 1599, 1599, 1599, 1599, 1599. This tells me that there is no missing data. Right? So now, if I come here, this is my test for missing data. This is my test for missing data. Is there any null value in any of the columns? It will tell me false because there is no missing data. I have already visually inspected it that there is no missing data. In short, there are two questions I'm expecting you to ask me. Now, if I want to be sure that this thing is a lie, I will go per feature. There are 12 features, Abi. I want you to go per feature. So if you look at now, this is a for loop. We've not done loops. I confess, we've not done loops, but that's your assignment. Go and understand loops and come and tell me, come and ask your questions. Or we may touch loop next week. But now, I'm saying that for every feature, feature is all this list. So for fixed acidity, for every feature in this list, go and check if there's no value in each column. So it has come back and you can see print. This is how I designed the reporting structure. Fixed acidity, there's no null value, there's no null value. So this is what we did last week. Right? Now, I want you to plot all the data. Let me see how it looks like because there is no null value. So I can work on it. Now, it printed all this. It showed me all the legends of the graph. And then, so I now want to go for each of them. Is there any outlier? Is there that so visual inspection of data is good because you can easily spot any outlier. What if null values are there? What if nulls are filled with NAs? We are going to get there.
I
Joy
think
here.
you mentioned it last week, sir.
Yes, I did. I did. This is just recap of last week.
And someone asked a question on this same issue
Which
that
issue?
someone just asked now. That's if there is any missing
No,
data or
if there is this,
information. And he
I,
said there will be a code for at least a number will show a difference. Maybe
yes.
where we have 1599, then maybe it might be 15991. Then
Mm-hmm.
it's so that it won't be equal all through.
Samuel, you have retentive memory, and God will continue to bless you. Say amen. Everybody say amen for Samuel, even if you are muted. Amen. Right? Yes, we are going to get there. That's what I'm building up to something. Yeah, in this place where I live, they'll say, let him cook, let him cook, let him cook. I'm cooking something. So now, in this scenario, like right, I as an analyst, I will be interested in three values gone because I want my model to be very accurate. Majority of the values are landing here. But if you look at this one, Oribakan is looking somehow. This one too is the only one that is here. Is the only one that is here. They will be points of interest to me. So I'm going to come here and say, there is one that is greater than 1.4. Give me, this is volatile acidity, I mean. Give me that value that is greater than 1.4. I will filter it. This is how to filter. This is how to filter. Give me that value that is greater than, it is showing me the value. So usually when I'm at work and they give me this kind of thing, I will not go, these are specific outliers. They call them outliers. They don't behave like usual data. What should I do? If they say, they look at the theorem, they look at the physics, because I, as a machine learning engineer, they can put me in my company, they can put me in cooking, they can put me in laundry, they can put me in any section. They need me to derive intelligence out of their data. So I will work with someone that is a subject matter expert. That what does this signal mean? What does this data mean? What does this sensor mean? If this graph is looking like this, does it mean normal behavior? So if I'm now gonna ask them, this the volatile acid is greater than 1.4 and is the only one exhibiting that thing, is this an abnormal scenario? So if I don't have anybody to tell me, I'm going to remove it. I will exclude it because I want the most generalistic behavior in the data. But if they say it's normal, very good. Because normalcy or generalism means repetition, right? There's a pattern to it. So do you understand? So like this one now, I can see this three. With this three confuse my model. You understand? So I think we discussed this yesterday. Like this one now, citric acid. I think I checked citric acid. I will now go and check. Is citric acid the one causing confusion? I think okay, this is it. This is the one that I did up there. So I'll do correlation.
Question.
Hi Deborah. What's your question?
Hi. What if the data is string and not numbers? If it's string, you can't plot it, right? So
If
how do
it's
you know what are the outliers or what are the values of, I guess, data that is causing issues with
so
your?
good. So yes, if it is string, and so say for example, hmm, you are cooking.
Mm-hmm.
When you are cooking your gas cooker, there is max, there is mean, there is 0, 20, 40 to control the temperature or the intensity of
Mm-hmm.
the right. There's max, there's mean, there's zero. Okay, that is numeric. Um, you want to bake. When you are baking, there is bake or broil, right?
Mm-hmm.
There's bake or broil. Now, when the sensor is entering the data, it will say bake or broil, bake or broil, bake or broil. That sounds like
Mm-hmm.
this.
Are you saying you should classify it into?
No, so if that is an intelligence or a data point, I'm going to first encode it. I should do something
Mhm.
like that. So instead of bake, I will say wherever I see bake, turn it to 0. Wherever I see broil, turn it to 1. So I will change those strings to numbers.
What if there are multiple features like
What do-
big, dance, sing, break? What if there are multiple
So
features?
all those features will represent a column. Those column, I'm going to encode them into numbers. Those
I
numbers are what I will put in my intelligence.
okay.
Now, but that now begs the question. Some people, I was working on a project at work. They misspelled Arduino. Instead of Arduino, they sent Arduino, and
Hmm.
that corrupted a lot of the data. Some people can be bake. Instead of broil, they'll put boil. Instead of bake, they can put break, B-R-A-K.
Mm-hmm.
Now, all those things, this is where your feature engineering comes in. You understand? You now say, how many bake do I have?
Okay.
Or sometimes I will say bake. Give me all the features of bake. And if it is 1 million cells, I can't go through all the million cells. I'll now apply a what? I will apply a set. I just taught you set. I'll
Yeah.
apply a set to it to give me the unique values.
Mm-hmm.
So to show me bake, okay, bake is there, bake is allowed. Boil is there, boil is allowed. Break, you won't break it. Break is
Mm.
supposed to bake because
I
break.
see.
So those things, those incremental. Am I preaching? Am I preaching a message? Don't
Yeah.
worry.
Mhm.
You are, sir, you are.
Right. So we'll get there. I think I should do one more notebook to do all these things because these are things I face at work. Building the intelligence is not hard. Is the data, and that's why 80% of your energy comes on the data set. Hmm? So now we do correlation to know. Would you use regex in such scenarios? Yes, we can use regex in such scenarios. It's like Joy. Joy is like someone that Joy, sure you teach the next class. Eh? So regex is a way to manipulate strings. Yes, we can use regex in such scenarios, right? To search and to say, okay, or enforce that okay, anything like this should look like this, anything like this should look like this. So after finding this outlier and they say, oh, it is okay, right? I will now do correlation and then check how they correlate. So fixed acidity and fixed acidity correlate. But fixed acidity, how does it vary with volatile? 0.25. How does it vary with citric acid? 0.6. But I'm not interested in this. I'm interested in correlation table. What I'm interested in is what is quantity. Because this is what I want to classify quality. So all these values, fixed acidity correlates with this by 0.12, 0.3, 0.2, 0.1, 0.8. So I wrote absolute value. In some situations, it can be negative. You can see negative values. Negativity does not mean anything. The value does not mean anything. It just means that the direction, it just means that, the direction of variation. So some might be directed some might be so the correlation might be going upward, but some are correlated downwards. That's why it's negative. The value does not mean anything. The magnitude is what is important. That's why I always put absolute value to remove all the negative values. So now, so once what happened was we picked the highest correlated values. So um
Sorry.
yes, please.
Can you please explain why it doesn't matter, like the direction?
So direction. So say for example, um let's take two positively correlated values. Um, let's take a car. The proportionality in the duration you own your car, it is directly proportional to the amount of money you will spend in buying fuel. So if the person that has owned a car for 4 years and the person that has owned a car for 20 years, the person that has owned a car for 20 years would have spent, there's a probability that he would have spent more money on that car than the person that has spent it for 4 years, generally speaking, right? So that's positive correlation. That means it is it is it is moving in the same direction. The more time it is, the more money you spend, right? But now, if I now say that the length of time you own a car, the length of time you own a car is inversely proportional. It's basically direct proportionality and inverse proportionality. It's inversely proportional to the amount or is inversely proportional to the resale value. So you know that if I just have the car now for 4 years, if I've had it and I want to sell it at 20 years, the value after 20 years will be lower than the value after 4 years. So, but it doesn't mean, it doesn't take any power in the magnitude of the value. It's just showing that one is directly proportional, one is inversely proportional. As this one is increasing, it is reducing. As this one is increasing, it is increasing. That's just the meaning
Yeah,
of the.
yeah, I get that. But my question is, why do you say that's not important? Because that's telling me something about the data. Why is it not
Yes.
important in the
So
context of?
so machine learning models find relationships, right? They don't find it. So if they know that in terms of direction, like this is correlated, so far they are correlated, is the magnitude of the correlation that matter. So if it is direct and the correlation is 0.0001, it is irrelevant, irrespective if it's positive or negative. But if it is negative and it has a high magnitude negatively, it is a value that is very, very, very relevant. Do you understand?
That makes sense. Thank you.
Thank you. So after looking through the data and we see that everything is good, we've seen what is correlated and correlatable. What do we do? This is the code to just train the model. This is the code to train the model. This is where we ended last week class,
I
right?
have a question. In the
Yes.
code you ran before this, you said the threshold is 0.5. What is that threshold? Is that the number that is close to
Oh,
the
oh,
max?
so this was this was me trying to look for the most correlated values together. So the most correlated values together that have
Mhm.
threshold greater than 0.5 are, so 50% correlation are
Oh, okay.
fixed acidity and pH has a correlation of 0.683.
I
Fixed
see.
acidity, so I just looked for, so say for example, you and this is something we did when I was in school. You go to ShopRite and they say, tell me, this correlation is what they use to arrange products in shops. So, say for example, there was a time Pampers, they saw Walmart. Walmart is like the ShopRite version here. They saw that the people that bought Walmart Pampers were buying cigarettes. People that bought Walmart were buying cigarettes. Now, it doesn't mean that when people give birth, they now take up smoking to cope with the stress of giving birth. We don't know. We don't know, right? Um, we don't know. But does it now make sense that when they have Pampers on their road to go and get Pampers, because people that have Pampers have cigarette problem, let's just put Pampers and cigarettes together. So if you notice in many scenarios, right, after a period in time, when you go to the mall, they rearrange their products. They rearrange how they place their products, and then we'll be like, oh, where's the fish? Where's the meat? You understand? Everything has some form of intelligence to it because we've looked at receipts and we look at this person bought shirts. When he bought shirts, he bought shoe. When he bought shoe, so let's put all of them together so that even if that even if even if this person did not have mind of buying shoe, once they put the shirt beside the shoe, it will be like, I bought shirt too. I need to buy a shoe that is close to this because of different consumer behavior. Does that make sense? Now you see the power of correlation, right? So if I want to find any two or three features that are 0.3% correlation, maybe marketing says we want 30% correlation, that is good enough. And marketing says, okay, I'll just come here, I'll put 30% correlation, and these are the three features we need. Make sense? So I will continue now. So this is where now we have moved away from data analysis. We are delving bit by bit into machine learning. Now this is using sklearn. Now sklearn, what does it do? So me, by default, I always use this. This is used to drop null values. There's no null value, so this line is irrelevant for this one. So I create a copy of the data. Last week, one of the questions was, I expected you to ask me what this line meant. That means that nobody who knows what that line means.
on that line. You're trying to split the data into test and train set. What's the criteria for choosing what data you're going to use to test versus what you're going to use to train?
Hmm. Deborah, what's your
She
background?
answered your question and threw a question right back. Fantastic. That's amazing.
Hmm. Deborah. Okay. uh so Kelechi, that's one of the questions I was expecting you to ask me, right? If so, this is one of the tests. I'm not giving you everything, and I've not given you everything to know that I was expecting this question, right? So now, when Mr. Israel was teaching us the intuition part, he said a lot of things. If you go back to the classes, the first 5 classes we had, we know there was training sets, there was testing sets, there was validation, right? So now in machine learning, once you have done your data preparation, which is up to here, we have seen that our data is balanced, no missing data, everything is where it's supposed to be, right? We already know that. Now, the first question I want you to ask is, why am I dropping quality here? Why am I dropping quality here? I'm dropping quality here because I want my X to be my training set. I cannot train with what I want to predict. So the way it is that, for example, I'm going to come here. I'm going to copy this. All right. I'm going to copy this and then I'm going to paste it here. Right. Sorry. I'm going to paste it here. Now, me pasting it here is just to show some level of visualization about what data looks like. Now this is X. This is X at this point, right? I'm going to say display X. Kelechi, you see how powerful draw is? Wow. So look at X. So I displayed X, right? So I'm showing you what X is. X is a copy of file. X still has quality there. X still has quality there. So now I'm now going to come here. After I put this column here, I'm going to display X again. After this line, display X. So you can see in the first X, there's quality, right? In the second X, there's no quality. So I removed the line of what I want to classify or what I want to predict. I cannot put it, it cannot be trained, right? It cannot be trained with the data. So that's what this column is doing. Now, another way to do it is that you can filter out these features. You can come here and say, oh, X is equal to file this. This is another way to write it. Then you delete quality. This is another way to write it, right? Which now begs the second question you're supposed to ask me. You're supposed to ask me, what if I have a million features? What do I do? What if the features, like in a car, there are probably over 300 or 800 sensors? Am I going to be looking at all the features? Am I going to use all those 800 features to qualify a data? How do I know the most relevant features to use to qualify a data, to train a model? Does anybody has answer? Please, I'm opening
That's
the
why
floor.
you do the correlation, right?
Living quality there. Living quality there is exposed to the model, so to learn is
Is that
so
not
now.
why
Yes,
correlation?
that's why we do correlation. That's why we do correlation to know the strong ones there, to show the strong ones um that have strong correlation or relationship. But there are now very crazy forms of correlation called principal component analysis, which is called PCA, right? Which is called what? PCA. Now, but before we move into there, so instead of us using all these all these features, right? We can instead of us writing all this code, I can just write this code that I've made a copy, just drop quality. That is why. So this would replace this code. So I'm going to leave this code here as a comment, just in case you want to test it out. For people that will try the notebook, you can test it out and tell me. In short, I'm going to leave an error inside it so that people will tell me the error. So now that's what I did here. I dropped quality. So I now created another file for quality, right? Created so that it will be like this X, or the X is what I'm training on. Y is what I want to predict. So Y is my ground truth. X are the features and the ground truth. Now, training size is that 70%, I have 1599 rows. 70% of it should be used for training. The other 30%. So training is data it will see. So training is like your classwork, your examples, classwork. Your teacher will tell you this is right, this is wrong. Testing is the one that you will not see. It's like your WAEC. It's like your WAEC. That okay, IBK 18 alpha.
Yeah, fine, thank you. Yeah, so my own question is this random state. What does it do? I quite understand what you have been doing all through till this point, but I don't really know the relationship this random state has to do with it.
Okay, good question. So I'm going to show you something. Bam. Now, what random state does and why many people use it is to tell the kernel to seed the weight values. So, how will I explain it? So, in many situations, whenever you load your data or rechange your data, there's a tendency for your model to change the weight values. So it picks a state to pick the random numbers. So if you pick a random state of 42 and you've changed your value on a random state of 42, you can be 48. It can be any number. In short, you can remove it. You understand? In short, you can remove it. But if you remove it and you don't, it can take any kernel, or it's basically a threshold to tell your engine, your laptop, your NumPy engine, that I have trained with this value or with this set of random values. When you are training your model, stay within this state, so that when your models or different models will know. So if it goes to a random state of 55, it will go and start looking for different random weights again and random magnitudes. It's just basically, how will I put it, a background setting for your weights. So you want that background setting to be consistent, right? That's what random state does. That random state, make it 42. Don't make it random. By default, it is random. Don't make it random. All the weights and numbers that you will be going, just pick within this part. So it's in different random states are different bounds of numbers. So if it knows 42, the bounds of numbers will be consistent. So it's just to put some consistency in the random values to go and select.
I
I
have a
don't know.
question. If
Okay, yeah,
data
sorry. So another question that pop up from this is, so is it that the higher the value of the random state, the more stable it is, or the lower the random state? So
No,
which one is it?
the more consistent it is. I can pick random state of 1 or random state of 1000. It's just the bounds of numbers. Whatever one you pick, if I pick 55, right? So if I've started a random state or a train, because maybe I'm going to train different versions or I want to train on multiple model, I'll just keep a consistent random state. It doesn't mean, and just pick one. You understand? It's just like
Okay, so
a set of values. Just be consistent with it.
okay, just to kind of a tab it with something, right?
Yeah, like a constraint on the background of your processing.
Okay, okay.
That's
Thank you.
just,
Thank
yeah, it's a setting.
Um, I have a question. The
Mm-hmm.
data you're trying to train is not randomly generated. You have it in a file. So why
Yes.
do you have to select a random state when the
No,
data is not random?
it's not the data, it's the weight. Your model is going to come up with random numbers, right? You will now want to place it around. Israel, please come in.
Like the percentage of accuracy or precision. Is that what you mean?
Percentage of
What?
consistency. consistency. So say for example, my random number has been generated from 0 to 0.1 with a slope or gradient value of this. It will be consistent around every time I place that random state of 42.
Let's see.
Israel, you raised up your hand.
Yeah, sorry, my voice is a little cracky. I'm still recovering from cold. So let me draw a parallel from this to our class 5 or class 4. You know, when we were doing this TensorFlow playground thingy, right? Before you click play, the model has seeded some numbers on those network already, right? You didn't put it there because you've not clicked the play yet. So if you go to playground.tensorflow.org and then go to that network, you'll see some numbers. So those numbers doesn't mean anything. It hasn't learned anything. So that random state variable there is telling the random number generator to just use it as a seed. It's just using it as a seed so that by the time the model starts learning, you remember how those numbers were going up and down for some guys. So it is the number that it has seeded for one of those parameters that the model will now be nudging up or nudging them down tune
To get
tune the
answer.
model to the target answer, which is quality in this case, right?
Yes.
So yeah, if you don't put anything there, at the end of the day, the guy will still randomize it anyway because it's in the beginning that when it hasn't learned anything, they're just the weights are just random numbers. But when it has learned something, the weight will now be, you know, it would have learned the connection between those inputs 11 variables and the outputs, right? So don't stress too much about the random state. But
Yeah.
yes, if you set it, if you just sometimes it could help the model to learn faster, where where the numbers will converge a little bit faster. But it's not a make or break thingy for your model.
Just to answer Deborah, yes. So this random state, what Israel has stated is kind of foundation, is a seeding of it. But where the random state is related to the data is that we are using a train split. It will randomly pick 70%. So it won't pick 1 to 70. Randomly pick 70% and randomly pick 30%. But it will, if you want to use that train split, like for example, the Y the Y train is saved as Y train. When we want to test it, it will remember those values. So in any other future scenarios where it will remember how we divided the data set into 70% and into 30%. Do you understand? It will remember those random values or the randomization of how we selected the test value and the train value. Do you understand? So
Yeah,
it
that.
doesn't have to do with the generation, but it has to do with the division into train and test.
Yeah, thank you so much.
So now, in many scenarios, so I'm just going line by line. So we already understand this. Now, power transformer, the standard transformer, the standard scalar is just a way to normalize our data. We can train without it, right? We can train without it. I'm going to comment it out, but usually it is recommended. It is recommended. It just so what it does is it subtracts the mean of the data and divides it by the standard deviation. It's just a way to normalize our data. That's what this power transformer does. We create a scalar and it fits to the trained data set. So from the trained data set, so um, for example, if I say, oh, no, dot scalar, that's experience. So, is this thing drunk? So look at, so this will help me again. This is how I use it. This is how I use it. Though. I'll just say dir scalar. And then there should be something scalar underscore. Maybe I've forgotten. Scalar. Okay, so scalar dot lambdas. Yes, and then yes, underscore scalar. Sorry, scalar. So I'll come in scalar dot underscore scalar dot variance. So now this is the variance. This is the variance is using. So standard deviation is the square root of variance. So it will divide this by this variance. If I want the mean, so that's what it's doing. It's going through the data and finding the mean and variance of those values and using it to standardize the data. Right? So that's what it's doing to X tests. And because we want to maintain it, we will also standardize for the train and for the test data. So that's what it's doing. And then now we are using linear regression. We're using linear regression. So we train the data and then we predict. Now, so I'm going to remove
I have a
this,
question real quick, sorry, before you move on from
please.
topic. So I know you're transforming the data, you're
Mm,
normalizing.
yeah.
Why aren't you checking for the distribution of the data prior to normalizing it? Like, does that make
Oh,
sense? Like,
yeah, no, it does. It does, right? So me, it's just a standard for me. So you check so usually by default, right? You check the distribution of the data. I'm just assuming that for this exercise, it was to show you an quick introductory from EDA, exploratory data analysis, to machine learning, right? It's not intense EDA. Now we are supposed to check the distribution to see if it follows a bell curve or Gaussian distribution or whatever. But this is just to, so in the next one, we're going to check distribution, check how it balances. So this is just to show you state of the art practices or
okay,
methodologies. Make
okay.
sense?
Yeah.
So now, after we do this, we'll fit the transform by normalizing the test and the train, and then we train using a linear regression. And then, so it's telling us that our mean squared error, so mean squared error, this is what I used to find mean squared error. Mean squared error, where did I get it from? I got it from here. I imported it from here. I imported mean squared error from metrics, R squared error, explain variance error, um, accuracy error, and I also imported mean absolute error. So those are metrics. So which boils back to today's class. Today's class was supposed to be metrics to measure regression. So far, any questions? No questions. We thank God. Now, how do you know your model is performing well? These are some of the measures to measure it, like measures or metrics to measure that these models are doing well. Now, mean absolute error, mean squared error, root mean squared error, and R squared error. You understand? And R squared, not R squared error. My bad. So mean squared error is the summation, is the mean, basically the mean of all the errors. So error is what? True value, predicted value minus true value. So add and subtract, add and subtract, add and subtract, and find the mean. Now, mean squared error is just like Euclidean distance. The square, you are going to add the square, the square of the error, and you sum it up. That's the mean. Mean squared error is the square root of this, the square root of the mean squared error. That's it. Now, when you come here, you can see that we have a good model because the lower all these values are, the better. Now, mean squared error is 0.41. That's very good. Root mean squared error is 0.64. Square root of 0.41 is 0.64. Mean absolute error is 0.51. R squared variance is this. This is a very good error. So what did I do? I took a value. I think we did this yesterday. I took a value, a feature, a row from file. I converted it into, and I predicted it. And it's telling me that the quality of this wine is going to be 6. So this is how I tested my value. So if you notice, this 7.7, 0.56, these are my test values, right? All these value 803, 124, 350 is because of the seeding of 42. If I change the seeding, it will rearrange these numbers. We won't see it again. it is maintaining this value of division because I'm using the random state of what 42. It's not random, right? So if you look at this one, right? If I look at y test, you can see 803. This is 803, right? This is what 803. If you see, the quality is what 6. What did I predict? I predicted 5.8. So it's almost accurate, right? Make sense? So if you look at 7.8, so if I take this value, 7 points, if I take this value, I want to take it individually. I can take it collectively, which is here. Where is it? Ypred. Ypred is here. Ypred is there. So it's predicting, it's just a lot of values, right? 5.4. But I want to take them individually so you can see the quality as is. So 7.8, comma 0.17, comma, you save it into a list. Mm-hmm. 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 Please, any question? No. Hope I'm not moving too fast. Mm-hmm. Mm-hmm. If I give this and I predict, this is saying 1.41. I hope this is correct. So 124. 124. It is what? It is saying that it is 5. That's terrible. It is saying that it is 5 after predicting it.
Is it
It is saying
telling
it
us?
is 1. It is saying it is 1 after predicting it. What did you say? What was your question?
You are going kind of fast, actually. Sorry.
Okay.
I feel like you started going a little quickly once you started showing like the training. But is it showing the percentage accuracy? Like, is
No,
it
it's
telling okay, one like
so
what
this.
percentage?
What did you say?
So I'm just trying to relate it to what we've learned from
Yes.
TensorFlow. So when it's predicting the value, is it telling us how sure it is? Like, what's the percentage accuracy? Does it say that anywhere here? Maybe in the
No,
earlier.
so for that, and that's why I said so for other models, like maybe I don't know the one in TensorFlow, you were actually probably using images, right? The metric for those ones, precision, recall, accuracy, do, those ones are metrics for CNNs. For regressions, these are metrics you measure: mean squared error, mean absolute error, R squared. Do you
Okay.
understand what I'm saying? So now, the lower they are, you want all these things to actually be equal to 0, right? Or almost zeros. So right now, in this place, these values show very good results, right? They show very good results. They are very good results. And then we now want to test individually what we do as machine learning engineers. We're going to do so now. It's doing well on 803. It's doing poorly on 124. Right? We're going to take 350 and check it individually.
Sorry, I might be asking dumb questions. I'm a little confused. So, if I understand you correctly, 350 is what is that?
So if you look at in this place, we split
Where?
the we split into train and test. So now I printed out X test. X test is just showing all the random values that it has.
Mhm.
So in column, so it's the way it randomized the value based on random state of 42. It picked the first column, 124 column, 350, 682, 132, 6. It picked a lot of random columns. Do you understand? So now we can now take these columns individual. So it has predicted them based on this. It has predicted them here in what? Ypred. You can see I said Ypred should predict X tests. Now
Mhm.
this is Ypred. Ypred, come in, let me predict. Let me click Ypred. Ypred is showing me these values. That it is 5. The first value for prediction is what? And this is Y test. So Y test is saying that it predicts 6 for for this predicted 5.4. It predicted 5 for this 124. This is predicting 5 actually. 350 predicted 6 is predicting 5.6 for it. 682 it predicted it is predicting 5.34 for it. Do you understand what I'm saying?
Okay.
So the corresponding values of those, this is the actual ground truth quality, right? Quality. But this is the predicted values from the model. These are the predicted values from the model.
Okay.
Make sense?
Yeah.
So if I want to make this almost identical, I can say what did I just declare? What kind of data structure did I just declare? Who can answer the
Yes.
question?
List.
A list. Okay. I'm not sure this thing was error. I didn't give me error. Okay, that's good. So what did I do? What did I do? I rounded. So widespread. Eh, they give away. Israel. There are some people we will not give in this class. So what did I do? What did I do? What I did was it's giving me all these values in decimals. Quality is in integer, right? So what did I do? I said, I said for all the values in widespread that is in decimals, round it up to the nearest integer and convert it to an int. So, for example, I is 5.47, blah, blah, blah. It's going to make it a 5 and save it as an integer inside this list. So that's what it did. And that's why it is now looking like widespread, the ground truth. So that is what I did. Make sense so far? Make sense?
Mhm.
Kelechi, any issue?
Yes.
Yes, Samuel.
No, there is no problem, sir. I'm in a very loud environment.
Okay,
That's
no
why I'm not
problem,
able to
no
say
problem.
anything. Thank you.
There's somebody here, Bimbola. Any issue? Um, Olumide, any issue? Show me. IBK, Josephine, Adedayo, 12 miles. So before, because I know we are getting to okay. You will catch up. Ibom, where did I Jayele? Where did I leave you? I don't like the fact that you have to catch up. Do you have any questions so far? Hmm? I don't want to have to let you be catching up. I want you to go with me. I don't want to
Question.
abandon you. Don't leave me. Don't leave me. Yes. What's your question?
I'm just thinking like the next thing in my head that I would want to do. Can we put the predicted values and the actual values like in a list together and like compare if they're the same?
So
Just
if
to
I
see
say
what accuracy.
I'm going to do that now. And I'll say int y. So the first one, so we're going to print what true value. Widespread and then one I me and say oh okay True, comma. So, sorry, white test. I mean, what happened? What? Okay. Yeah. Sorry, me and my code were fighting. Yep, side by side, right? And then we can see that for this one, it predicted a 6, a 5, a 5, a 5, a 6, a 6, a 5, a 6, a 5, 5, 5, 5, 6, 7, 6. The true value is 3. He said it was a 5. So now we can see that 8, 7, um, we can see that for majority of the time, 7, 6, it has a 1% error or an error of 1. I'm liking this now. I like to go to that. Yes, please. You understand? It has a, aside this 3 to 5, that is 2, like quality of 2. Majority of it, okay, let me also predict. Let me also print the difference. The difference will now tell us where, you know, this. I want the absolute difference. I don't want to be saying negative and positive. Ooh, zoom. So now, so if you see just one, right? I feel so. Usually, in industry, there's usually a, at least based on this should have an allowance of about 1.52% catch. This is, he's saying it's 6, but he's saying it's 5. Okay, is allowed. He's saying it's 5, is 6, is fine. Aside this one, right? Let's keep going. It's going to be zero ones and everything. So usually in many companies, marketing will say, oh, you know what, there should be an allowable gap of this. But this still gives you some very good premise that it is 6, so but it's saying it's a quality of 7. So maybe it's actually a 6.8, right? Or a 6.5 quality of 7, right? And that's because I rounded it up. Maybe if I didn't round it up, I rounded it up. If I didn't round it up, maybe it would have been better. You understand? If I rounded down, maybe these numbers would have changed. So it's just a thing. This is where after you train the intelligence, you now do just some, aesthetics on it. But so far, do you understand what I'm saying? Does everybody understand what I'm saying? Hello? Good. So um so we have that. Now, like I said, these are the metrics for measuring a regression value: the mean absolute error, the mean squared error, the root mean squared error. Right. Now, what is the most important? The most important is usually what we target in the industry. We want the RMSC to be equal to MAE, to be very close to MAE. We want the what? RMSE to be close to the MAE. That shows, so even if the MAE is saying 500, is saying 500, and the RMSC is saying 1400, something is wrong with your data. You need to catch, you need to make sure. So if you look at this, what we have here, right? If you look at what we have here, the MSC and the MAE are somewhat close. We want them to be close. We will love for both of them to be 0, but we want them to be close. Now, I have put some notes here to show distinction between RMSE and MAE. And RMSE is usually the bias part of the metric. MAE is more robust, right? So MAE is the most important, but we want our RMSC. The best scenario is for RMSC to be close, very close to the MAE if they are equal. But RMSC can be greater than or equal to MAE. right? So just go read up. This is just distinction that okay, you train different models, different versions of different models, which different random states, and everything is changing, blah blah blah. And you now have different models that have different MAE, RMSE. Which one are you going to pick? That's what I want us to do now. So, what's the time? Oof, we're just we are in the time of teaching people installation, but there's something I want to get off my chest. I've been through a lot. Another exercise, which is this one. Please, do we still have time? Yeah, yeah, this is it. Why did I not make time? Now, do we still have time? Just in case, I will not want to keep us beyond. If not, we can go to we can treat this next class. Mm, should we continue? Yes, no, no, yes. Let's treat it next.
We should take it to next week.
Let's treat it next class. Let's treat it next class. I want to respect your time. All right. So it's 2 o'clock. You have the notebooks. I'm going to prepare this lecture and also put it on the classroom. I'll put all the links. Please, everyone should go through the materials. Like I said, this is very, very incremental. We will not go through any of this. From next week, we are going to go through this. We are going to go through maybe 2 more regression, and then we're going straight into convolutional neural networks. I'm supposed to take 4 classes, so I'm almost to the end. And this is our target. We're supposed to do work in this realm. We're supposed to do regression, which we've done. We've done, yes. We're also supposed to do this, which I plan for us to do next week. And this, they are very close. So we probably will do this too next week. And then we're supposed to do some text classifications, all those things before we go into the wonderful nature of generative AI, right? Which is the talk segment. So please go through them, come with your questions. We are not doing this just to tick an activity. You want assignment. I think your assignment is go through it. Go and go through your Abraham, do you have a question?
Yes, sir. Sorry, I joined in quite late, but
Yes.
well, this is the first time of joining the classroom. I want to know exactly, though I'm following, but I just don't want to say I know it or I just don't know. I just really don't know what is happening. So I want to know, is this the first class, and then after this very whole thing, are you done with it, or probably there is a second class you are going to take?
So this is the seventh class. Now
Wow.
on the screen, I am showing you like our Google Classroom. If you're on our Telegram and WhatsApp group, we have we have from class one, the assignment, class two, class three,
Okay.
up to class six. I will upload class
Wow.
seven after this and the recorded messages. Now go through those stuff. Some of them what's your background?
Okay, I did auto engineering.
Okay. Do you have some programming background?
No, but then I want to tap it from this platform. That is
Yes,
why I joined.
and you're in the right place. We are doing an applied version of them. So go through them, and
Okay.
you have access to message. Once you type a message, you can ask me. I will get the notification. You can fix a time you can
Okay.
check through and everything. So this is the seventh class. It's easy, 2 hours. I think you can catch up between now and next time.
Oh, okay. So probably if I go through all these materials, I can catch up with.
Yes, yes. You
Okay.
understand? And
So
like this class, there are some classes that were repeated just to show that people should understand it. So some of the classes you might even skip them.
okay.
Make sense?
Yeah, makes sense. And last one, please. Where will I find this very docs file?
Um, it's on our platform on Telegram and on WhatsApp. Are you on our
Okay.
WhatsApp platform?
Yeah, I'm on the WhatsApp platform. I'm on the Telegram platform.
Platform?
So
The link should
I
be shared.
well, will I have to check if I would find a classroom?
They will share the link and you can just add it up. Or Israel, you can just join the class, right?
Okay, then I'm going to do
I
that
will
right
drop
after
the
this
link to the
session.
class again.
It's going to drop the
Yeah,
link.
I'm glad, sir.
No problem. Are you from Ghana?
Yeah, I'm in Ghana actually.
Oh, which part of Ghana?
Yeah, I'm in the capital city, Accra.
Accra. Accra.
Yes.
Makes sense. I have a lot of Ghanaian friends there.
Wow. I
Um,
really want to learn about this thing, so probably looking forward to catch up with
no,
you, and then I take it up
no
from there.
problem. No problem. We're here for you.
Okay. I'm glad, sir.
Yeah, no problem. So, any other questions from anyone? If not, how many people want to stay behind to see how to install the stuff locally? Please identify in the chat. Dayo or
Hi.
Hi. Okay, yeah, yes, please. So just put, if I see up to 10 yeses. Okay, don't worry. One yes is enough. Don't worry. But just iterate so that we'll know how to somehow you raised up your hand. Do you have something to say?
Just saying yes.
Okay,
No,
okay,
just
okay.
saying yes.
Okay. Dio too, you are muted. What's up? You want to say something? Okay. So so right now the class is over. You have an assignment. Now, before you leave, this is your assignment. I'm going to drop this link to everybody. Hey, you people want to I need to give people what happened? Something sounded. Please just give me a few reviewed. Um, no. Dio, please, can you mute? So based on the steps that we've done, I want to drop a link for you to. I want to drop a link for you to for you to for you to do a particular one. The next class, you're going to tell me what you've done and how you know. Yeah, this is perfect. So this is the problem statement. This is the problem statement. What you need to do is you need to do exploratory data analysis. You need to analyze investment. I'm sure everybody wants to do this. Everybody wants to invest, right? So that's what I want. These are the features and the columns they've given you. So you have acquisitions, you have degrees, you have funding, you have relationship, you have everything. Wait, hold on. Um, okay, no. Okay, so now what you need to do is you need to predict which startup will succeed or not. This is what you need to predict, which startup will succeed or not. This is the problem statement. This is the data. You just download the data. You might need to, this is my account. You might need to open an account on Kaggle. This is the account. So assume that the data is clean, but you will check for data, check for description, check for distribution of the data, and use the notebook you have to train it. Right? So this is your assignment. Please, I'm pasting it in the chat. Everybody, Bimbola, Deborah, Joy, uh, Kelechi, Josephine, Emmanuel, you have your assignment. Please, it will be sent to the classroom. Yes, it will be sent to the classroom. So you are going to come in, you are going to share insights, you are going to submit. Please submit your notebooks. In short, I'm going to tell you what I want to see. So you're going to tell me, there's a section for hyperparameters. I want to know what hyperparameters you use. I want to know everything, right? From all the previous classes, I want to see it. So I think this will probably help us know and help us study what we want. So thank you very much. So the next set of words coming out of my mouth will be how to install Jupyter, get started with Jupyter, get started with no. Is this a regression problem? Yes, because all you have is numbers and you're predicting numbers. You know what? I think yes. Now, if you don't know how to solve it, come with your questions too. Come with your questions, right? So Joy asks, is this a regression problem? Joy asks, is this a regression problem? I said yes, because they are giving you words, so you might have to do so. Let's look at the data. Let's look at the data. Mhm. This is it. Ooh, okay, you know what? Don't do it. This is don't do it. Don't do it. It's fine. It's fine. I take it back. I take my word back. No, we're not yet at this level. Um, this is it. This is better. Let's look at the data. 0 0 0 0 0 0 0 0. Yeah, good. So what are you supposed to do? You want to find out, is there any relationship? What is the overall score? What are the best? Can we predict who is going to terminate, who isn't? So let's try this one. Let's just try this one. I want you to use correlation to find out what are the best relationship between the data, right? Once organ to the pilot. Okay, you know what? Your assignment is just go through the notebooks. I'm going to plan an assignment for next class. Go through the notebooks and let's see. And if possible, I would send the data offline for your assignment. Make sense? So don't let me tension you people so early. It was a good session, Abby. Let us so all those that want to see installation, let's go through installation. So now I'm going to go through the link I sent to you. So for us to have an offline version, I came to this place. Now, what's wrong with this link? This link is supposed to have loaded. Okay, it's not loading. So let's go to install. I'm sure most of us using Windows. So now, so the first step. So because I'm using Mac, it's telling me to install this, which I've already installed, but I'm coming. I don't know why this link is not going. Okay, let's go. Um, so first, let's download Anaconda. Please, am I talking to myself?
And we are together.
Okay, okay. So we need to install what? Anaconda. How to install? So now you can see if you are using Windows, how to install Anaconda on Windows, or how to use install pip on Windows. So you can install on Windows using any of these two links, right? So I'm going to do this. Just see why. So I already have. So I'm using Mac. Okay, good. So I already have Jupyter Notebook running on my system, right? So this is Jupyter Notebook. And if you look closely, it looks like what we have on Google Colab. If I can say import. So I'm not online now. Import NumPy. So now You can see it has imported it now. So how do we get here, right? How do we get here? First things first, you need to install Anaconda. So you are going to go to your browser and say install Anaconda Windows. For those using Windows, install Anaconda on Windows. It's going to take you here, and you are going to download it. You are going to download it. Now, I cannot download it because I'm using a Mac. Now, when I download it, it's going to
Sorry,
download.
sir.
I'm going to install. Yes.
Sorry, sir. Can we
Yes.
download it on our phone for now and then copy it on the system?
Yes, you are free. But without
Oh,
installing it, we cannot continue.
no,
You understand?
okay.
So what you can
Okay.
do now is I can send you this link. This link will show you everything. You can see Jupyter Notebook comes with Anaconda. It will show you everything you need to do now. Installing on Windows, installing on Mac. You understand? And what we can also do is that if you can come to class, if you agree to come to class 1 hour before next class, we can do that and just zoom into the class by 12. All right. So install on Windows, install online. So once you install Anaconda, you're now going to come here and say Jupyter Notebooks. Sorry. It will take you to a navigator, and then once you have installed, I think it actually comes ready-made with all the branches for all the packages for Jupyter Notebook. Makes sense. So I'm going to paste this. I'm going to add this to the class. Just follow the links. The links I give you have very instructional this that I would rather you come and ask me your questions, right? Because many of you, like I said, are attending the class through different medium, different things. But I can send you the link that you can follow to get the installation on your system. I think that is rather the best version to get an offline version. Make sense?
Yes.
So if that is all, any questions so far?
So what about me that is using Mac? You didn't say anything about my
Well,
Mac.
I'm going to send the one for Mac. I'll send Mac. I'll send Windows separately. So no problem. Hmm?
Okay, so thank you.
All right. Thank you much, sir.
Okay.
Thank you very much, sir.
No problem. You're very welcome. So thank you very much for attending today's class. I
Thank you
hope
so much, sir.
one way or the other message was passed across. Thank you for those that are participating in the class: Deborah, Joy, Kelechi, Samuel, and those that are not participating in the class. Thank you too. Just your presence here means a lot. So if you have any questions, please interact with us through any of our platforms. And we are always here for you. Our goal is for you to be able to be superheroes for Africa. Mhm. Thank you. So I wish you a very lovely weekend, and also upcoming week. So take care of yourselves. Bye bye. Or if you want to stay to chat with me, we should turn it to a machine learning podcast. So take care of yourselves. Have a lovely day. Bye bye.
Bye, sir.
Bye bye.
Bye bye.